Hey guys, so we're going on our next section of the motors. Um, just to be brief, we talked about rotor resistance of a wound round motor, that's its torque characteristic. We talked about three-phase synchronous motor, it starts with an armature winding. We talked about how you control the speed of induction motor. It depends on the frequency, and that's what those VFD, variable frequency drive, we control the frequency of it now, but it's also controlled by an armature winding. It's also controlled by the number of poles in the motor. The speed of the winding motor is normally changed by switching contacts. We talked by that, and so on. And we talked about consequent pull motor has two speeds. So now we're going to go into the method of braking. So braking is, okay, so think about this. DC, it's called DC injection. It's called injection braking. We want to stop a motor. So how could we stop a motor? We can't really stop it with alternating current. We could stop it with a brake. We could shut it off. But a way you can stop a motor with a VFD is called DC injection braking. So what does DC do? DC is like that straight line current that has no intermittency. It's just strong, it's straight, and it holds. So injection braking is when they take DC current from a VFD and they inject DC current into it and it stops the motor. So DC braking would be in DC braking would be injection braking. Reconnecting a running motor to act as a generator. What do we do to reconnect a motor to act as a generator? So if we want a motor to act as a generator, we have to, it's called dynamic braking, okay? You don't really see that much in the field. The DC braking, you'll see a lot of that, but dynamic braking, you won't. What are the two primary types of motor enclosures classified by NEMA? Two primary motor closures classified by NEMA, what would they be? So the two types of motor enclosures classified by NEMA are totally open and totally closed. Motor enclosures, you either have to have a sealed one or an open enclosure. Okay. An open AC squirrel cage that makes use of form wound coils that are all formed and made, and insulation system is known as a what? An open AC squirrel cage motor that has coils and insulation is known as what? It's known as sealed windings. So it's an open motor and the wound coils are insulated, so they're sealed windings. NEMA frame design designation for gasoline pump motors is what? What frame would it be? Well, you don't have the book to look it up, but I will tell you the NEMA frame is frame G. NEMA frame for gasoline pump motors would be frame G. So that's not really important. You're not going to really run into that ever. The letters FLA. So what do you think FLA stands for on a motor? What does it stand for? I'll give you a tip. Full L. What is the motor drawing? Load. And when you draw more and more of a load, what goes up? Amps, full load amps. So FLA on a motor is important. It stands for full load amps. That's the most that a motor can draw. All right. That was number 18. So question number 1. So reconnecting, what method of braking do you use when DC is applied? When you use DC to brake the motor? Is it A, injection braking, B, friction braking, C, dynamic braking, D, regenerative braking? Okay, number 2, or number 14. Reconnecting a running motor to act as a generator is known as what? When you reconnect a motor to act as a generator, what do you use? Injection braking, friction braking, regenerative braking, or dynamic braking? Which would be D. Number 15. The two primary types of motor enclosures classified by NEMA are what? General purpose and guarded, totally open and totally enclosed, guarded and semi-guarded, non-ventilated and externally ventilated. So 2 types of motor enclosures. 16. An open AC squirrel cage motor that makes use of form wound coils and an insulation system is known as what? You got coils and then you put insulation around them. Would it be A, semi-guarded, B, sealed windings, C, non-ventilated, D, explosion proof? Number 17. The NEMA frame designation for gasoline pump motors is what? 1B, 2C, A is B, B is C, C is G, D is H. I don't care if you get that one right or wrong, it's really not important. The letters FLA on a motor nameplate, what do they stand for? FLA stands for A, fuse blast application, B, fast lower arm, C, full load amps, D, full load armature. So those are your questions. I'm going to talk for like 1 more minute. The other things on the nameplate's really important. The nameplate's going to tell you a lot of things. It's going to tell you RPMs, how fast that motor turns. It's going to tell you, okay, for example, it's going to tell you 3-phase, single phase. It's going to tell you it's 120 volts, 208, 230, 240. Remember, if you've got a 240 volt system, you can't use a 208 in it. But if you've got the 208, 230, but if you got or 208, 240, but if you got a 230 volt system, you can use the 240 volt. So one don't go with the other. Keep in mind what I talked to you about the 208 wild leg. 208 wild leg, you'll know because that B phase. You should always check breakers in a panel, no matter if it's full or not full or half full, just to make sure each leg is 120 and there's not a wild leg on that B phase. And it should always be in the B phase. If it was done prior to 70, I think it's 2, it'll be on the B phase. So you should always be aware of that. And you know the telltale signs. Every B1 has a blank in it. Blank, 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 blank for the B. You know, A, B, blank, A, blank, C, A, blank, C, A, blank, C, A, blank, so on. So nameplates are important. Full load amps are important. How much your motor will draw is important. The horsepower is important. You know, like somebody you might go into a bar someday or a restaurant. Somebody say, "Hey, can you replace my exhaust fan motor?" Well, you get up there and you get this old crappy, cruddy motor out, and it has no name tag on it. You have no idea what it is. It's got a 1/2-inch shaft, and you're not going to know what to do with this motor and what to get. But what you can do is you know that it's an exhaust fan for a kitchen, and there's no speed control. They turn them on and they run. So chances are it's going to be like maybe a 6-pole to 8-pole motor. It's going to only run at maybe 700 RPMs. It's going to run slow, and because you don't want an exhaust fan running at 1800 RPMs or 3600 RPMs, you're going to suck all the heat out of the building. So that's something you need to keep in mind. So for nameplate, there's a lot of stuff that the nameplate tells: voltage, current, how many amps it's going to draw, full load amps, phases, A and B phases. It'll tell the frame designation, and generally, if you can't find it, you would take that motor down to KJ Electric, call up KJ Electric, come down and say, hey, I'm not sure what this motor is. There's no nameplate. Can you match it up for me? And generally, they're pretty good and they can match it up for you, but depends on what it is. So, all right, guys. Well, that was it. I'm out. So, have a good day. I will talk to you guys tomorrow, and I will plug you in for another video. All right, have a good night. So this video is actually Tuesday's video. Tomorrow I'll pop on the video for Wednesday. All right, see ya.